Welcome to the Long COVID podcast with me, Jackie Baxter. I am really excited to bring you today's episode. Please do check out the links in the show notes where you can find the podcast website, social media and support group, as well as a link to buy me a coffee if you are able. You should not rely on any medical information contained in this podcast and related materials in making medical, health-related or other decisions. Please do consult a doctor or other health professional. I love to hear from you. If you've got any suggestions or feedback or just want to say hey, then please do get in touch. I really hope you enjoy this episode, so here we go. Hello and welcome to this episode of the Long COVID podcast. I'm delighted to be joined today by two guests, and we're going to be talking about a recent research study, and we're going to get into what all that is in just a moment. But my wonderful guests today are Dr. Rudy Tanzi and Dr. Edmarie Guzman-Velez. So before we get any further into this, would you guys just like to say a few words about who you are and what do you do?
Well, thank you so much for inviting us to the podcast. I am an assistant, until a month ago, I was an assistant professor at Harvard Medical School, Mass General Hospital. Currently, I'm an assistant professor in the Department of Neurology at the Rutgers Robert Wood Johnson Medical School and Center for Healthy Aging Research. I recently led the study that we're going to be talking about in collaboration with several colleagues, including Dr. Tanzi, with long COVID and neurological symptoms associated with it.
And I'm Rudy Tanzi. I'm a professor of neurology at Harvard Medical School, and at Mass General Hospital, I direct the Genetics and Aging Research Unit, which is 11 labs carrying out preclinical Alzheimer's research. I also serve as director of the McCann Center, which funded most of this study that we're hearing about today, where we study the role of supplements, natural products in treating neurological diseases. And we're very proud to be part of the study that Dr. Guzman led.
Perfect. Thanks so much, guys. So maybe the first thing to do is just to take a little sort of snapshot of what is this study that we're talking about. And then I'd love to talk a little bit more about like the hypothesis and why did we actually think that this might work in the first place? So do you want to give us like a little bit of an overview?
Yes, of course. So, obviously this was inspired by the alarming number of individuals who had COVID-19 and haven't fully recovered. And this was a clinical trial. So we were looking at whether nicotinamide riboside, it's a form of vitamin B3, could help improve or elevate levels of NAD+, which we can talk more about later. And if this in turn could help reduce or improve some of the symptoms that are most common in people with long COVID, particularly this cognitive difficulties. So a lot of people talk about it as brain fog, and also other symptoms such as fatigue, sleep difficulties, and others that people experience, and that can interfere with their daily activities. That's kind of a very short summary. So yeah, clinical trial trying to figure out whether this could be helpful for people with long COVID.
And I would just add that, NAD+ has been shown to play a key role in cellular resilience of cells and the energy in cells. And in COVID patients, NAD+ levels drop.
Mm-hmm.
And this NAD deficiency leads to all types of issues that could likely contribute to long COVID symptoms. And so nicotinamide riboside is probably the easiest and best way to increase your NAD+ level. So it just seemed that this was an obvious trial to initiate and see if we could help long COVID patients by increasing NAD+ levels using nicotinamide riboside, in this case through the Niagen from Niagen Biosciences. I also just want to state for conflict of interest, I am a longtime consultant to Niagen Biosciences and hold equity in the company as well. And so for that reason, I was not directly involved in the trial execution, but involved with the early conception and design, and then later the interpretation of results to follow conflict of interest rules at Mass General Hospital.
Of course, yes. So can we talk a little bit about NAD? Now, it's alphabet soup, isn't it, in sort of medical research world, I think. So I guess what would be a really sort of good place to start would be, what is NAD? What does it actually mean? What is it? What does it do in the body, and what do different levels of it mean, or what different levels of it might mean?
I can start. NAD stands for nicotinamide adenine dinucleotide. It's basically called a coenzyme. It allows various activities to take place in the cell, especially giving the cell energy to do what it needs to do. The batteries of our cells are mitochondria, and mitochondria tend to start getting defective in cells, especially in association with long COVID. So NAD plus is a way to supercharge up those mitochondria again. And it plays a role in what's called the mitochondrial respiratory chain. In other words, how mitochondria supply energy to cells. And so if you have an NAD plus deficiency, everything your cells are supposed to do, they're going to do less well. And you see this manifest as problems with immune resistance, with fatigue, with just generally how much energy you have. Even psychiatric symptoms or depression, anxiety, agitation, sleep. NAD plus is so important. And so it's unfortunate that COVID particularly targets NAD plus levels. And this probably is a major, if not the major contributor to symptoms of long COVID.
And do we know what the mechanism is in that COVID reduces the levels of NAD in the body? Do we know like what it is that it does there, or do we just know that it does happen?
Edmarie, I don't know. Do you know? I don't know if we know the mechanism.
I don't know. And I think one of the limitations is that we need more research on this. If you make a quick look, you're not going to find much information out there, particularly specifically to COVID. But what is out there, I think it's very convincing that there's definitely an association between the virus and depletion of NAD plus.
I mean, without getting deep in the weeds, there's these enzymes called PARP enzymes, and they help maintain your genome and protect cells from dying. And so the COVID virus does, by activating these genes, it causes the NAD plus to be used up. So in terms of, a precise molecular mechanism, that could be one possible way in which, you're depleting NAD plus by activating. And it may be that the cell's trying to protect itself from the virus. So it's activating these PARP genes in order to maintain resilience, but that's energy consuming. And that means the NAD plus gets used up, like using up a battery. So that could be one way in which it happens. But we don't know exactly all the details.
Right. But what we do know is that the levels of NAD do get depleted in people with long COVID. And that is something that you can then look at in terms of their study. How do we increase those levels? Or is it how do we stop them from being depleted? Or maybe both.
I should probably clarify that patients who are hospitalized with COVID, who have severe COVID, have NAD plus levels that are depleted. So we're assuming that with long COVID, this also happens. But I don't know if there's been a study that shows specifically this in long COVID. It's in severe COVID cases requiring hospitalization that you see this drop in NAD plus levels.
Yes, that's correct. Yes.
Right. So it's a sort of assumption that it does it in the body of anybody with COVID, or is it you thinking, or is it more severe in people with who go on to develop long COVID, or is this something that's not really been looked into?
Well, that's part of what we wanted to answer with the long COVID study, is actually see if if we already know what happens in the acute stage, may that be explaining, at least partially, why this group of people have not fully recovered. And to kind of also go back to your first question, so in this case, it wouldn't be so much as preventing the depletion, but we are assuming that there's already a depletion, we're trying to increase and get it back to normal levels for that person.
Right. Okay, cool. So how does now you're going to have to remind me what the name of the building block was, but it's the Niagen is what you've used in the study, isn't it? What is that, and why is that relevant to the NAD levels?
Yeah, Niagen is nicotinamide riboside, which if you look at the pathway to making NAD plus, nicotinamide riboside or NR gets turned into something that's abbreviated NMN, and then that turns into NAD plus. But if you want to increase NAD plus levels, you would use nicotinamide riboside, and then in the blood that would be taken into the cell and then turn into NMN and NAD plus. If you use NMN to do it, NMN would have to be turned back to nicotinamide riboside in the blood before the cell could take it up. So it's a less direct way to increase NAD plus with NMN. NR will do it directly, but it's just along the synthetic pathway to NAD plus. NR is one of the steps along the way and the easiest one to pharmacologically affect to get NAD plus levels higher, which has been shown to do.
Right. I wanted to exactly say that it's already been shown in animal models and even smaller clinical trials that this is an effective way to increase NAD plus levels. So, that information was already available, which made us confident that, in fact, we would be able to increase NAD plus in this population.
Because that was kind of one of my thoughts that was just going through my head. Like, if you want to increase the NAD levels, can you not just give people NAD? But no, because it would have to break it down anyway.
NAD doesn't really make it out of the gut. If you just orally took NAD plus itself, it would never make it into cells. Just like NMN, even though it's one step closer to NAD, the cells won't take it up, so it has to be reverted back to nicotinamide riboside or NR before the cells can take it up. Then turn it back into NMN and into NAD plus. So NR is the most direct route to do it.
So it's kind of like the smallest, well, probably not the smallest, but the smallest building block that the body can sort of handle in order to then build that back up. I'm visualizing Lego here.
Yeah, no, you got it. Yeah.
So you've got to get those little pieces in order to build up to the bigger your Lego castles and things. I'm showing that I'm still a total child. I do have Lego castles in my house, and I don't have children. They're mine.
I use Lego metaphors all the time, just so you know.
Aren't they brilliant? Aren't they brilliant? Because I all understand them. So NR, can we just talk a little bit more about what actually is it? We've talked about how it's this small building block and it will build up into NMR, you said, and then up to NAD. But what actually is it?
It's a form of vitamin B3. And so it's a chemical. It has a structure.
Mm-hmm.
And for most things in the body require synthetic pathways, right? You have the building blocks, and then they are modified by enzymes to turn into A, turns into B, into C, and then finally get D, in this case, NAD plus. So nicotinamide riboside can be found in small amounts in some foods like milk and yeast, and even a good IPA has nicotinamide riboside in it, believe it or not. Although I'm not suggesting that's how you get it.
I actually didn't know that one.
Yeah, it's in beer. But it's basically a chemical building block, and it's technically a vitamin. It's a form of vitamin B3, which is also related to niacin. Niacin is B3, but this is an alternative form of B3 related to niacin.
Right. And that is one, I mean, people with long COVID and ME/CFS they've, been through and tried all the supplements, and niacin is one of those ones that does get talked about. So I think people will probably be familiar with that one. So let's talk a little bit about the study itself. We've kind of talked about, what is this stuff? Why do we want it? And what does it do? Let's get into the study. So how did the study work? What was your kind of procedure? Was there a certain dosage? Well, I mean, there must have been a certain dosage that you used. And how did you kind of monitor it? What did that kind of all look like? We'll be right back. I'm interrupting myself for a second to tell you about long COVID breathing. The fabulous Vicky Jones and I have teamed up to bring you long COVID breathing. We are both passionate about sharing our expertise and experience of the breath and how incredibly helpful that can be with long COVID. We've worked together to develop a course that is specifically tailored to those with long COVID. It's a 6-week course with 12 sessions, all delivered online. The community feel and learning that we're all sharing is such a joy. To find out more information and to sign up for our courses, workshops and other shorter sessions, please check out the link below, longcovidbreathing.com, or email longcovidbreathing@gmail.com to start your breathing journey with us.
Yes, I'm happy to share that. So the dosage was 2,000 milligrams of nicotinamide riboside per day. And so what we did was that we invited to participate people with long COVID who had been infected with COVID-19 at least 2 months prior to starting in the clinical trial and who were experiencing brain fog or these difficulties with memory or language, and also at least 2 other symptoms. And then these individuals also, none of them were hospitalized during acute infection. So they experienced mostly mild to moderate illness. They stayed home when they had COVID instead of having to be hospitalized or in the ICU. And then everyone started taking placebo after, we did all the screening to make sure that they comply with all eligibility criteria. And they took placebo for 2 weeks. And then at 2 weeks, we did a lot of testing. So we collected their medical history, all the medications that they were taking, including other supplements. We did some objective cognitive testing. So these are neuropsychological tests that have been validated to measure different aspects of thinking. But in addition to that, we also wanted to understand what was their perception of their cognition. And so we also gathered data using validated questionnaires about their perception of their cognitive changes, their perception of their sleep quality, of their fatigue levels, their symptoms of depression, anxiety, trauma. So we really, really tried to get a good picture of what it was that they were experiencing because of COVID. And so at that point, once they completed all of these tests, some people then switched to and started taking nicotinamide riboside. And they took NR for 20 weeks. And then there was another group that continued on placebo. And then after 10 weeks, they switched and started taking NR. And we did this for several reasons, but one, it allows us to see placebo versus NR, right? That's kind of the usual model that you hear about when you do clinical trials, but also this would allow us to compare people with themselves, right? Because you have some people who were in placebo and then they switched. But also we would provide everyone the opportunity to receive the intervention in case, they could benefit from it. And so on all of these tests that I spoke about that they did at baseline, they also did in the middle of the clinical trial when the placebo group then switched to taking NR, and at the end. And so that way we could track for 20 weeks, people who've been taking NR for 20 weeks, people who've been taking NR for 10 weeks, and placebo for 10 weeks. And we were able then to monitor, right, changes in all of these symptoms that I mentioned. And also they provided blood. And with that, we are able to measure NAD plus. So we can also track changes over time in NAD and see how these changes in NAD relate to their experience of different symptoms.
Right. So you're able to actually measure those levels. Did you take the blood samples before, like right at the start, as well as in the middle and at the end?
Correct.
So you could literally track it through.
Yes. So everyone has at a baseline when no one, actually everyone had been in placebo for 2 weeks, so there's no intervention. And then in the middle after 10 weeks of the baseline, and then at the end, which would be 20 weeks.
So, I mean, I love that you have done this in the way that all the participants get to experience taking NR because, I don't know if it's normal, but most of the clinical trials that I've heard of have the placebo group and the intervention group. So one of the groups don't actually get to take the intervention, and some trials then give them the opportunity to take it afterwards. But for the benefit of the trial, it's two separate groups. So I don't know if that's the normal way of doing it, and you guys have done it differently, or if it's just one that I've not heard of before.
This is a more powerful, that group to group placebo and treatment requires huge numbers and it's very expensive. And frankly, we wouldn't have been able to afford, between the funding from Niagen Biosensors and the funding from McCann Center, we wouldn't have been able to afford a classic placebo versus treatment group trial. What we're doing at the McCann Center now is trials where you use a person as their own placebo. And you also have, so you might have people who are on placebo and then they switch over to True Niagen and you look at the difference. That was one group here. Or you have another one where you're looking at they're on Niagen the whole time, then they go back, Niagen in the beginning and then continue on Niagen. So there's an ability to do a small comparison of placebo versus Niagen by having the group that's for 10 weeks on Niagen and 10 weeks on Niagen again versus the group that's 10 weeks on placebo, then switching to Niagen. But the main power comes from what's called the intra-individual and the crossover analysis going from placebo to Niagen, comparing to the people who are on Niagen the whole time. And that's where we saw the results. And it just shows that that's where the power is versus just a classical trial. Do you want to add to that, Edmarie?
I think another key factor here is that we already knew that NR was safe too. So we're not concerned with, we can't give this to everyone because we are not sure if this, we already knew based on other trials that this was safe, that, all of them could take it. We were not worried about any, significant or severe side effects. So I think that also helps with feeling comfortable on being able to offer this to everyone. And one of our collaborators, Dr. Stephen Arnold, this is what he does and develop clinical trials. And so I think between all of us, we agreed that this would be a powerful design.
And it makes a lot of sense as well. I mean, with long COVID, for example, you've met one person with long COVID and you've met one person with long COVID, everyone, there's so much variation in the condition that it actually seems to make more sense to compare like person A to person A and person B to person B, particularly if you've not got like thousands of people in the trial itself. So it does seem to make a lot of sense to me. I've just never heard of it happening before.
All the trials we're doing at the McCann Center now are intra-individual. So you don't, instead of a placebo group, you look at them before you give them the treatment and you track maybe biomarkers in the blood, or you might track, in this case, NAD+ levels, and you look at various symptoms. And then then you put them on the treatment, and then you see how they do afterwards. So it's called an intra-individual. In fact, a biostatistician at Mass General, Hiroko Dodge, just published a paper in Alzheimer's and Dementia. They're calling it the SLIM. I forgot what SLIM stands for, but it explains this novel. It's this novel trial design where you get much more power from fewer people by having them serve as their own placebo. Yeah. And that way, no one's denied the drug either. I mean, it's always terrible when you have a trial and half the people or one-third of the people, and I don't know it, but they're not getting the drug. I mean, everybody wants to be able to benefit too.
Yes, I always thought it sounded a little bit cruel that half of the people who signed up for the trial didn't actually get to potentially benefit from it. So it's a way of, as you say, avoiding that as well. Yeah. So let's talk about kind of like the the results. What did you find from your sort of, your data measurements, what before, during, and then after? And as you said, you had a variety of measurements, some of which were, blood and sort of more objective questionnaires, and then, things that are maybe a bit more subjective because they're self-reported. I'd love to hear a bit about how that all came together and yeah. We'll be right back. Hey there, I'm just jumping in for a second to see if you're enjoying this episode. If you're finding it useful, maybe you would consider sharing it somewhere, a friend, a group, or even on your Twitter feed. If everyone was able to share just once, we'd be able to get this information out to even more people who really, really need it. So please consider sharing somewhere if you possibly can. I hope you enjoy the episode, and thank you so much.
Of course. So the first question that we needed to answer was did we indeed increase NAD+ levels? And we did, actually quite significantly, by threefold in 5 weeks. Because actually, something I failed to mention is that the blood is collected every 5 weeks during those 20 weeks, not the other measures, but those are. And so we could see that even with just 5 weeks, the NAD+ levels at least doubled. So we were successful in doing what we wanted to accomplish. And then the next question is, what does this mean clinically? And so when we compare the placebo group with the people taking NR, we actually didn't see any differences in terms of their cognitive performance, both in objective and subjectively, or any of the other measures that have to do with mood and sleep and so on. And even when we take the smaller group, actually, it was a group of 21 people, so not a huge group of people. When we compare the placebo to the NR phase, we also didn't see any significant differences. Now, one of the challenges was that only 18 people completed the complete clinical trial at the end. And this was mainly related to things that were totally out of our control, particularly COVID reinfection. So between 2021 and 2024, we had many waves of COVID. And so people were getting reinfected. And once they did, we needed to exclude them. And also some people, leaving the state and just kind of going on with their lives. But what this means, and the reason why this is relevant, is that because we had a small group of people in each group, we decided to do some more exploratory analyses that we had not contemplated at the beginning. And so what we did was we knew that everyone, regardless of what group they had been in, everyone had taken NR at least for 10 weeks. So the NR group who started NR from the beginning took 20 weeks, and the other group took 10 weeks, right? So then we lumped them together. We lumped the people who had taken NR, the first 10 weeks of NR, and then the placebo group, the 10 weeks of NR. I don't know if that makes sense, but now instead of having 18 in each group, we had over 50, 43, I think. So over 40. This increases our power, and this increases our ability to detect differences. And this is where we saw changes. So when we compared these individuals, that 10 weeks of taking NR compared to their baseline, we saw that there were significant differences in their symptoms of depression, sleep quality, and fatigue. Specifically, that they were reporting that they were experiencing less fatigue, better sleep quality, and less symptoms of depression after taking those 10 weeks of NR.
So it's a different way of looking at the same data.
Right.
So it gives you a sort of different outlook on it, does it? Is that a right way of putting it, maybe?
Yeah, so when you are ready to start a clinical trial, you already plan, oh, okay, this is the specific analyses that I'm going to do, right? In this case, we were comparing placebo versus NR. And we didn't expect that we were going to end up with a lower number that we anticipated. And so after we saw the small number, like, oh, there's this other way that we could look at the data that is also a very valid way, even though we didn't contemplate at first, that could help us, given that we have more people, that we could help us see if there are any changes. The more people you have, then the better, right? You mentioned actually earlier that, I don't remember, I can't quote you word by word, but you say when you meet one person with long COVID, you meet one person with long COVID or something like that. And what that means, right? There's so much variability, right? There's, people are so different even when they have long COVID. So the larger the number of people, then the better you're able to capture who is this working on. So what this is telling us that when you do put these people together, you have more people, and we can see that there are improvements, that some people are improving, are feeling better. Right. The next question would be, who are these people, right? Is there a specific type of symptoms, or I don't know, that predicts, oh, this person is more likely to benefit or not. And those are things that we need to do in the future.
I think, what people who are ill want to know is, what's going to help. And, a question like, are there certain people with certain symptoms or certain types of symptoms, all sorts of different symptom clusters. And, is the sort of neurological symptom cluster, or, whichever particular one that you maybe have more of, is this more likely or less likely to help you? And then, you got to be kind of targeted, haven't you? That the scattergun approach doesn't really work. So it's kind of like, where am I going to target? Is this something that's worth me looking into, or is it more likely to help other people with a different symptom cluster, and maybe I should look elsewhere? So that sounds like it would be really useful information to have.
Right.
If you look at the data, first, the direct placebo to treatment group, we didn't see an effect, right? But with this unique intra-individual, we saw that. But it was, for cognition, it wasn't all cognition, right? It was executive function, but most would argue that executive function, the ability to make decisions, and the right choices, is probably the most important part of cognition. Of course, memory and recall is important too, but for everyday life, executive function is important. And that's the one, unless you correct me, Edmarie, that was improved. And there was, the improvement in fatigue and depression, and sleep quality. So, at least, you don't want to overextend and say, okay, it helps every symptom, but at least for those using this trial design, there was a promising improvement.
Yeah. And again, it comes back to, if you're not well, that there isn't a silver bullet. There's not one thing that's going to cure you. And I'm not sure there ever will be, but there are all sorts of things that can help. So if what you guys have worked out from doing this trial is that doing, taking this supplement or indeed any other supplement that people find in any other trial, is something that is going to help people even a bit, with a certain amount of symptoms to a certain extent. It's something that might be worth doing. So that's still useful information, even if it's not going to, solve everyone's problems and make everyone 100% better, because that's quite a tall order, isn't it?
It's also so weird that an over-the-counter supplement has a
Mhm.
clinical effect, and that's not common. It's always great when it happens.
So is this a supplement that people can just go out and buy and follow this sort of similar protocol that you guys did in the trial? And is that something that, I could just wake up tomorrow morning and go and do? I mean, again, you're not giving medical advice here.
Maybe Edmarie can address this, but the dosage was higher than what's recommended on the bottle. Like if you buy True Niagen,
Mhm.
it can come as 500 milligram capsules, and they recommend 2,000 milligrams. This was a 2,000 milligram dose. So I'd be careful here about saying, go beyond the recommended,
Mhm. Yes.
dosage on the bottle and take double that. But that was what was used here in this trial. So that would require further thought and discussion, I think.
Yes. No, I totally agree. And that is another question: is 1,000 enough? 1,500, we don't know. But for this clinical trial, we did use 2,000 milligrams a day.
And you guys thought that was safe because you were monitoring it and
Mhm.
keeping an eye on these people, and it was under sort of supervision.
We were monitoring, but also we were not. There had been another study or studies that had used 2,000 milligrams, and they had not seen any significant side effects. So we felt comfortable using 2,000 milligrams, and that, our participants were going to be safe.
The IRB, or Institutional Review Board at Mass General, reviews this, and they go into all the empirical data of, has this dose been used before, just like Edmarie was saying, and is it safe?
Mm.
So the fact that they approved the study means that they felt this was a safe dose. It's just not the recommended dose.
Yeah.
It's double that.
Yeah. And obviously anyone adding supplements into their routine should do so under medical advice. um, what I'm curious about, and I don't know if this is something that you measured, you said you measured your NAD levels at the beginning and the middle and the end of the study, and that they had significantly increased during the study, which is obviously awesome. It's what you thought was going to happen, and it did. So that's always good, right? Um, what I would be curious about is, did those NAD levels that had risen up while you were doing it, did they remain up there or did they drop back off?
That's a really good question, and for the most part, they remained high.
I guess eventually they would drop off and stop supplementing, right?
Right.
So
It's really interesting because, and once the article is actually available to everyone, it's open access. So when you look at the first graph, you see that the people in the NR group, after baseline, it's like super, it skyrockets. There's a significant increase, whereas the placebo stays pretty flat. And then when the placebo changes to NR, then you see a very similar increase, as the other group. So, it's very clear that the NAD plus levels are increasing, and then they stay up pretty high throughout the trial. We also our participants were amazing, and they were very good at taking NAD plus. And we do measure whether they're skipping days or not. And for the most part, everyone was taking NR every day as instructed.
I think it's also worth mentioning on the cognitive test, going back to that this trail making B test, right? So I don't know how it works is you have to, connect numbers and letters in order. So 1 to A to 2 to B to 3 to C. And they're all over the place, right? And so so you measure how fast you can do it. And it requires you to be able to focus, right? So if you're like confused, agitated, even highly depressed, it's hard to focus and say, and be able to say 1 to A and 2. Now where's the B? Okay, there's the B. Oh, and what's next? Oh, yeah, 3. So it's how much time you take. And I've done a lot of these, trials in Alzheimer's disease, which is my specialty, and we use trail making B. And I thought, knocking 8.4 seconds off of the test
Mhm.
For those who are on NR after 10 weeks versus placebo.
Wow.
Or was it after?
It was when we put 10 weeks baseline versus 10 weeks of NR.
Right. So after 10 weeks to get 8.4 seconds off that test is pretty good. And we'd be really happy about that in an Alzheimer's trial. And so I thought that was one of the more impressive things about the study for me. I don't know about Edmarie, but maybe I'm just biased.
Yeah, that does sound impressive. I mean, what I'd be curious about is and it's probably another trial, is are there people, particularly maybe where we talk about repeat infections or where people are, I mean, people get sick with all sorts of things all the time. And, is it just COVID that reduces these levels of NAD, or is it any infection? And, is it the sort of thing that might be useful for people to supplement, when they get sick, as a sort of precautionary measure? And I don't know if that's anything that you guys have looked into or are thinking of, but again, it's maybe something that people could do if you thought it might work.
Increasing age. I'm the oldest one on this podcast, but age decreases NAD plus levels, and so I often will provide family and friends with a list of supplements that I found to be helpful in our research lab, right? And I give a disclaimer: this is not clinical advice. We don't have clinical, evidence yet. Here we have some clinical evidence for this one, but this is what I do personally. But I usually have Niagen on that list for that reason, that it's usually older people who are concerned about their brain health and what's going to happen. So I include Niagen on there along with other supplements and natural products that I've tested in model systems that we feel can help stave off, age-related brain pathologies. But yes, NAD plus is something that goes downhill with age, and it's because cells get old. It's like, think about cells like toys with batteries, and mitochondria are the batteries. And, you might have a cell with 10%, 20% of the mitochondria are like dead batteries. And you need to need to recharge them. That's how I think about NR.
I like that way of explaining. I'm going to steal that.
Okay.
No, that was really good. COVID-19 is not the only thing that will reduce NAD plus levels, as Rudy mentioned. There is another study where they took people who were infected with COVID-19, so it was in the acute stage, and they combined NR with 2 other supplements, and they did see that this group recovered faster. So it may be that this can help with the acute stage. We don't, there's, to my knowledge, no one has done this only with NR, but at least it may be, based on those results.
Just anecdotally, when February 2020, I had the first COVID strain, and I was so sick. I mean, and so I treated myself with supplements that are meant to reduce inflammation, and I used True Niagen. I was taking 1,000 milligrams of that, and I wrote to an Ayurvedic doctor I know, and he told me an Ayurvedic concoction I can make at home to help with my lungs and my breathing. And it's amazing how it helped. It was, I mean, that's all I did, and I got through it. But I don't know if it was just a Niagen, but it was one of the few things I took just to help me do it, because I said, okay, I'm getting attacked. I didn't know anything about NAD plus and COVID at that time. Nobody did. But I just knew that I needed more energy. I needed to refuel my cells.
In fact, one of the things Rudy mentioned inflammation, and we know from other studies that there is an association between increasing NAD plus and reduced inflammation, which can be really bad for the body, including the brain. And so one of the things that we would love to do is also see, and we hypothesize that those people with higher NAD also have lower inflammation, and that may be contributing, right, to those who are feeling better over time.
Yeah, especially the immune cells in the brain, what we call microglia. They are normally housekeeping and cleaning up debris, including the amyloid plaque and Alzheimer's. But if they lose energy and start to become what's called senescent, they're more likely to turn into inflammatory cells. They convert from housekeepers to killers, and they become neuroinflammatory. And so the way you stop that is you give them more energy. Well, energy, comes from things like ATP and NAD plus. So, and luckily, Niagen, nicotinamide riboside, affects the brain, and energy there. So, I think that may have helped play a role here too. With, as Edmarie was saying, is we didn't directly look at indicators of neuroinflammation, but if we look for biomarkers of that, we might have seen something there too.
And that makes total sense because, it's one of those things that's talked about a lot in long COVID. And, it is that, reducing inflammation, which is healthy in the body anyway, isn't it? But, particularly in long COVID, if those levels of inflammation are higher, then, more important to find a way to reduce that. So if this is something that can be done that might help that, then that's an added bonus, isn't it? So you've just mentioned about, potentially looking at inflammation and stuff like that. And, the results from this trial are really interesting, especially with the use of the different analysis that you talked about. So do you have plans to sort of continue in this kind of research with more long COVID and expanding the study that you've done into something else? And, what are your kind of plans around that?
I would love to. With the data that we have now, some of our plans are to look at some of these biomarkers of inflammation. Everyone also wore a Fitbit during those 20 weeks, so we may be able to look at whether they were engaging in more physical activity, which is what we want. And if sleep was improving as measured with the Fitbit. But we definitely need to do more, collect more data, do new trials. Actually, someone, I think it was yesterday, was asking me, long COVID tends to be more common in females. And so she asked, oh, is there a difference between the results for females and males? I'm like, I don't know. We need more research and more trials, larger trials, so that we can address some of these questions that are important, and that may help us understand this better.
And also the McCann Center, working together with the Alzheimer's Clinical Trials Center at Mass General, did a Niagen trial on Alzheimer's disease, small trial. And while it was too small and not properly powered to see changes in cognition and memory, we were able to look at biomarkers of the pathology in the brain, looking at blood plasma biomarkers. And there we did see an effect on one of the pathologies in Alzheimer's is tangles, the tangle formation, tau tangles. And we did see an effect on that biomarker. So I would like to, at the McCann Center, now we're doing a whole slew of Alzheimer trials with natural products and supplements. And so I do plan on doing a trial where we get Niagen added to other supplements aimed at lowering neuroinflammation and clearing out the plaque and tangle pathology. Of course, with a supplement, you can never make any claims about a disease because it's just the rules, right? but we can still test them to see if it helps and put those papers out there, about what it does in disease. Although, I think there are rules about not being able to put that on the bottle, but, we can at least generate the data.
Yeah. And like you kind of mentioned earlier, that there have been other studies done with Niagen. And, okay, they weren't specifically long COVID, but that it might reduce inflammation, that it has stuff to do with the brain, so it's not like you're coming in with no information beforehand, I guess. You already know that it does certain things. So you can use that to build another study in a certain group on that kind of, going back to Lego analogies, aren't they? The kind of the building blocks of studies that have been done previously.
Absolutely. And I think clinical trials like these, in addition to helping us understand if a symptom can improve or not, it also allows us to understand the mechanism a little bit. So, what is going on in the brain and the body that may be explaining this? And we spoke about inflammation, so on. So this is also telling us something about the role of NAD+, which is also important for developing future potential interventions.
Yeah.
Yeah, we were also very fortunate to be able to work with Charlie Brenner. And, Charlie Brenner was the guy who discovered nicotinamide riboside linked to cellular energy. So it was under his supervision that the NAD+ levels were measured, and we couldn't have had a better person do that.
Yeah, we had a really great team of investigators working on this.
And I guess that's the thing with a research project, isn't it? It's like it is a team, and I guess that team includes your participants as well, because you can't do it without them. And it's a big joint effort, I suppose, isn't it, to make it a success? And I can't remember who it was that said to me, but it was someone who worked in research, and they said actually whether you get a positive result or a negative result in your research, it doesn't matter, because it still gives you information. So it either tells you, okay, this does work or this doesn't work, but it's still solid information. And actually, you guys seem to have had a positive result, certainly with some people. So that's really cool.
And in 10 weeks isn't that long a time to get a result.
Absolutely.
Even before this study, I was telling folks who had long COVID to try this. Say, look, there's no clinical evidence yet. There's a trial going, but there are preclinical lab studies that can predict whether things would work. And with that caveat and disclaimer, you don't have clinical evidence yet. As long as it's safe and available, you can ask people to try it. And so I got lots of anecdotal data back from people, and I emphasize anecdotal, not clinical, who just said, yeah, this really helped me feel better. And but it's nothing like real clinical data. And so Edmarie ran an amazing trial.
Amazing. And just finally, you mentioned something there that made me think, ooh, you said 10 weeks isn't very long, and it's not. So is something else that you could look into is, okay, what would happen if they were to take it for longer? Would they get more benefits for taking it for a longer period of time?
I mean, keeping the NAD+ levels up, right? I mean, even after 5 weeks, the NAD+ levels were already up, right?
Yeah.
And like threefold. And so that's pretty darn good.
Absolutely.
If that's going to be the thing you need to do to feel better and to alleviate the symptoms.
Yeah. And is there like an upper level of how much NAD is kind of okay in the body? Like if you were to keep taking it when actually your levels were already high, would that potentially be dangerous, or is that not something that you'd need to worry about?
I would say take the recommended dose of Niagen again, not what was used here. And, if you're using Niagen or nicotinamide riboside every day at the recommended dose, then you're going to keep those NAD+ levels higher. There are lots of studies suggesting that it can help with resilience to cancer and other diseases. But you don't want to take too much. I think it's a difference between taking too high a dose versus just having it on a daily basis to maintain your NAD plus levels, especially if you're older when the NAD levels naturally start to decline.
And something that I think is relevant too is that when our participants started the trial, we asked them to stop taking anything that had an R or niacin or anything like that, because then we had no control over, how much NR they were consuming. Therefore, that could definitely potentially change our results. So these individuals were taking those 2,000 milligrams of NR and not anything else that like niacin. And I think it's pre-workouts. I have a lot of niacin, so they had to stop.
This was the most successful trial we've had for the McCann Center with Edmarie, and the Alzheimer one was at least a good beginning for a trial. It needs a bigger one. But I would love to see more trials, and in fact, hopefully in collaboration with Edmarie at Rutgers now, where we add True Niagen, add it to other supplements that can work synergistically with it.
Yes, and as you mentioned at the beginning, and Jackie, a lot of these individuals are taking other supplements. I think this is very relevant to this population too, who is not only taking NR, they're already combining this with other supplements. So I think that's definitely a really important question. And actually, I think that's one of the reasons why I love working with participants, because you learn so much from them. Right, you think reading articles and whatnot, but it's not really until you interact with them that you really get to see, okay, this is what's really impairing or interfering with their daily activities, or a lot of people have a lot of insight on what's happening, and so you get a lot of ideas by just talking to them.
Yeah, and it's that sort of true collaboration, isn't it, which is just really beautiful. Guys, I'm really excited to see what comes next. And, one of the things I've learned from speaking to doctors and researchers like yourselves is that one research study is the launch pad for the next one. So it'll be really exciting to see where you launch next. So thank you so much for being here, for giving up your time, for coming and chatting to me. I'll make sure that links to the paper and anything else you've mentioned go into the show notes. So if anyone wants to follow up with that, please do that. And yeah, thank you so much for being here. It's been awesome.
Thank you. And thank you for doing this podcast.
Yeah, thank you very much. Thanks, Jess.
Thank you so much to all of my guests and to you for listening. I hope you've enjoyed it, or at least found it useful. The Long COVID podcast is entirely self-produced and self-funded. I'm doing all of this myself. If you're able to, please go to buymeacoffee.com/longcovidpod to help me cover the costs of hosting the podcast. Please look out for the next episode of the Long COVID podcast. It's available on all the usual podcast hosting things. And do get in touch. I'd love to hear from you.